Hi there, students. We're going to do matrix multiplication today, not to be mistaken for scalar multiplication. And the first thing I want you to do is to look at these two matrices. Step one says, is it defined? Now, it's not defined under adding or subtracting, but let's see if it's defined for multiplication, because the way you do that is to put the order underneath each one. So this is 2 rows by 3 columns. It's a 2 by 3, whereas this is 3 rows by 2 columns. To see if they're defined, you actually take the inside values and see if they're equal. Are they equal? Yeah. So it is defined under multiplication. Number 2 says, what will be the resultant matrix? To find the resultant matrix, you actually just look at these two numbers, the outsides. It's going to be a 2 by 2, and that's how you can figure out what is going to happen. Now, on my 2 by 2, now you don't have to do this every time, but at first, please, create a map of your rows columns. So in other words, I know it's going to be a 2 by 2. On a 2 by 2, isn't this row 1, column 1? And this is row 1, column 2. This is row 2, column 1, correct? And this is row 2, column 2. So on my map, that's what's going to be multiplied. I'm going to multiply row 1, column 1. I'm not going to, let me rephrase. I'm going to dot product that. Row 1, column 1 will go there. Row 1, column 2, when I dot product those things is going to go there, etc., etc. So this may or may not help. I'd like you to try it for the first couple and see if that helps, and then you can drop it later if it does not. So now I'm going to do this problem for you. So I'm going to start out, I'm doing number 4. I'm going to dot product row 1 with column 1 and put it in this driver's seat, if you know what I mean. So here we go. Dot product 1 times 7, 2 times 9, 3 times 11. If I add those up, that's 58. So 58, because remember dot product is the sum of the products. So that one's done. Now I'm going to do row 1, column 2. Row 1, column 2. 1 times 8, 2 times 10, 3 times 12, and I get 64. Okay, now I'm going to do row 2. Row 2 times column 1. 4 times 7 is 28. 5 times 9, 45. 6 times 11, 66. So that's going to be 14, 19. That's 10, 13. I'm getting 139. And now I'm going to do row 2, column 2, and put the answer there. Dot product 4 times 8. 5 times 10. 6 times 12. 4, let's see, oh, I carried a 1 I don't have to. So that's 4, and that's 8, 7, 154. And there, I hope, is my answer. Clean things up a bit. Okay, I want to do another one with you, but this time I'll show you how, whereas I used to do that at first, let me show you an easier way to set it up. Since we know the dot product, we can sort of do something that might be easier. Let me set these up by their order. This is 2 rows by 4 columns, whereas this is 4 rows by 3 columns. So is this defined? Yeah. 4 is equal to 4, so it is. What will be my resultant? It's going to be a 2 by 3. So it's going to equal a 2 by 3. I'll put it up there. But let me show you. You used to do these little brain puzzles. And I'm going to show you one in class. And this might help. I'm going to copy it in my own hand, the second matrix. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is my first one. I'm sorry, that's the second one. The first one I put down here after I skip. See, I don't double dip on this line. These have their own lines. Now I start a row down here going horizontally because it's my horizontal pieces. 2, 4, 6, 8. And what's going to happen is this. Let me get a highlighter. If I set it up like this, it just makes everything kind of easier to organize. I'm going to take the dot product of this column, this row, and I'm going to put the answer right there. And then I'm going to take this row, this column, and I'll put it there. And then I'm going to take this row, this column, and the answer will be right there. And it's just, and then follow in suit with the rest. And it makes it, to me, easier to organize, and maybe for you. Let's see. So if I take 1 times 1, 3 times 2, 5 times 3, 7 times 4, and add that together, 28, 29, 35, 50, I get 50. See how it fits really nicely right there? And now for the next one, I take, to get this, I'm taking this row, this column. 1 times 8, 3 times 7, 5 times 6, 7 times 5, 65, and 29 is 94. Now, let's do this one. 1 times 9, 3 times 10, 5 times 11, 7 times 12, and add those up. I got 178. Now let's do the second one. Can you see how this helps to organize? Or maybe not. Maybe you could get it the other way. 2 times 1 is 2. 4 times 2 is 8. 6 times 3 is 18. And 8 times 4 is 32. Let's see, that's 40. 50? Is it 50 again? No, that's 50. It's 60. Sorry. I really need to do this because I need to practice my adding and subtracting. I'm getting rusty. Okay, grabbing another color. So now 2 times 8, 2 times 8, making sure I'm in the right place, is 16. 4 times 7 is 28. 6 times 6 is 36. And then 8 times 5 is 40. Add those up, and I got 120. And now for the last one, I'm going to take another color. 9 times 2 is 18, highlighter. 10 times 4 is 40, then 66. And 8 times 12, what is that, 96? Add those up, and I got 220. So here is my resultant. So did I get, I erased it. I was supposed to get, I wrote it back down. I was supposed to get a 2 by 3, and I got a 2 by 3. So hopefully doing those columns will help you work that out. Now I'm not going to work this one out for you, but if you want to pause and try it, I'm going to shine the answer here in just a few. Let's make sure it's defined. So we have 4 rows, 4 columns. You have 4 rows, 1 column. So yes, it is, and you're going to get a 4 by 1. So try this, see what your answer is, and there's your answer. I hope you did that right. Okay, I was going to try to explain the identity matrix, and I decided not to because I was having trouble explaining it, so let me just show you what it is. Let's say that you had to multiply this by something and get the same thing. I need the same values. What would that array look like? Well, first of all, let's look at, this is 3 rows by 2 columns. So I know if I'm going to have a 3 rows by 2 columns, right? First I'm going to look to see if it's defined. And this would have to be 2. And if I need it to be a 3 by 2, right, because I have to take these outers to make sure that that's what I come to, it's a 2 by 2. So the identity matrix for this is going to be 1, 0, 0, 1. So let me show you really quick that it is. Don't know why I did that. So 1 times 1 plus 2 times 0 is indeed 1, correct? And 3 times 1 plus 4 times 0 is 3. 5 times 1 plus 6 times 0 is 5. And I could finish it up, but see, what happens is I get this. This is my identity matrix. So what would it be for this? Let's look at this. I have 5 rows and 2 columns. So what would the identity matrix have to be? I know it's 2 by what? Right? 2 by what? Well, think. I need it to be a 5 by 2 when I'm done, correct? So it's going to have to be a 2 by 2. Does that make sense to you? So because it's going to be a 5 by 2, it's still going to be a 2 by 2. It's 1, 0, 0, 1. One more, if you don't mind. Here I have 3 rows, 3 columns. I want a resultant of 3 by 3. So I know the inside has to be 3 for it to be defined, right? And so how am I going to get 3 by 3? It's going to have to be another 3 by 3. It's not always the same thing. Notice 5 by 2. Okay, so it's going to be a 3 by 3. And so the first value is going to be 1, 0, 0. Then a 0, 1, 0. And a 0, 0, 1. And that's my identity matrix. So we're going to do a few of those. I'll make the connection later. Good night. We're at 11 minutes. You guys take care.